peak pressure, you will definitely find a compliance, right? You will definitely find a compliance. Okay, imagine in her case, it would be equal to the maximum compliance whatever she would have obtained in tympanogram. The peak pressure was pretty much same, minus 15, right? So minus 15, she got 1.1, right? Or 0.6. 0.6. 1.1 was there. Okay, so 0.6. So that means 0.6 was the. Imagine when I am pressing further negative pressure inside the airpin. Did you see compliance is going on decreasing? Did you see? Yes. So this is what happens if you do it without compensating for the peak pressure. Instead of measuring 0, now it is minus 1, minus 0.1. Did you understand? Okay, so equating pressure and compensating for the compliance is very important. So whatever her compliance at the peak pressure would be considered as X. In this case, 0. Did you understand? So this value comes to 0 means it has found that peak pressure and whatever is the compliance at the, in this case it is 0.1. Imagine if I increase further.
Hello? Ma'am, call for you.
Right? The value increases.
Okay, thank you.
You understand? So when we increase the intensity, right, the amount of contraction of tympanic, the stapedius muscle is more, right, and that gets reflected as further reduction in compliance. And as we increase intensity, you will find there is greater reduction in compliance. So the best way to find out is suppose if you have any doubt, so first put it to the manual mode of stimulus timing. Press start. Right? If you are not sure about whether the stimulus is or whether the reflex is present or absent, right? Keep pressing that. Did you see this? This is what is the compliance with manual mode. That is, if the compliance is close to 0 now, which is at the peak compliance. Now, when I am pressing the stimulus, you see this compliance graph showing a negative value, and it will be sustained as long as I am pressing it. See?
Yes.
Yes. So this reduction is what is graphically represented.
For manual. For manual mode.
Yes. Okay, so this is what is manually represented. You understand? So you see it as a graph, but otherwise this is what happens. Okay? You understand? So now this is the time of compensation, and I am seeing that it is compensated. Did you get it? Okay, so if the compensated compliance should be always 0 throughout your reflex measurements. If it fluctuates even without stimulus, then that is wrong. So then that means your chances of finding out, your chances of recording as artifact is 0.03. It is reading now. Whereas when I started compensating, it was at 0. See that? Exactly at 0. With time, if I leave for some time, what will happen is, slowly it will go to either positive value or negative value. That is because of slight movements of the probe. Right? So if you keep a probe on in the air for a longer time, then also there will be a reduction in automatic change in compliance. Right? Okay. With means the baseline changes automatically. See this? Now it is 0.01. Right? Previously it was 0.03. Remember? Okay, very minor changes. This is very minor change because it slightly moved. Did you see that? See? And this is more associated with movement of this probe unit. Did you see that? Right? If there will be change in compliance even without presenting stimulus. Okay, so we have quite a lot of options here. We can say, means we can take whatever one. You see here, threshold seek, right? So I have not switched it on right now. It is off, right? Threshold seek off. So I go for threshold seek on. Before that, I want to configure. What do you mean by? What do you mean by threshold? Right? So I go to configuration, and I'm saying that minute change. That is what I want to change, right? Minimum change. So I want to change it to 0.03, or I set it to 0.3. Right? And then starting intensity 70, and then stopping intensity 95. We will slightly increase it to 105. Right? Okay. And then on, and then start. You see what happens. Instrument does it automatically. 70, 75, 80, 85, and it is looking for what?
Minimum.
0.3 reduction. Will it come? That's a quite large change. My scale itself is 0.1. Did you get it? So there is reflex, but the instrument is not considering it as. Where did it find? 85. Right? 85 considered as reflex. So wherever you want to mark, right, you can mark that as reflex, or if you want to put NR, you can put as NR. See this? I can put this as no response. One NR appears and goes. Can you see? Okay. So now this is marked. Whenever you think that there is a lot of high frequency or mass dominated pathology or anything like that, you can change.
And
right? Okay. But then why? Actually, there is no studies which says what is the value of B or G. How does the reduction in B or G is changed in probe tone, right? Or even at 226 also, what happens to B or G we don't know, right? It's just an yes. So this would be more. I am more confirmed about this reflex than previously while doing automatically. While doing automatically, so it was very short burst of time. So you have on time and off time here, right? What I want to do. Quantity 1. You understand? Suppose I can do this by increasing the number of quantity also. Now I compensate again. So now exit. So now when I press start, when I press enter, it will present more than one stimulus at that particular intensity. You see that? So now also I can be sure that it is a reflex or not, rather than you changing it manually and doing it. Okay, so given same setting, 3 times I have replicated. So all the 3 times it come pretty much the same level. So I can be more sure that this is an reflex compared to what for this stimulus, for this intensity, isn't it? So my cursor now shows 0.14, whereas if I change the position, the compliance value changes. So what does the instrument detect? Peak compliance. So apart from this, we know that we have different stimulus we can use for recording acoustic reflexes. What are the stimulus we can use? Clicks. Did you understand? So we can use different stimulus. What are they? Clicks, broadband stimulus, narrowband stimulus, etc. Right? Pretty mostly what we use? Pure tone. What we use? Pure tone. 500 Hz, 1 kHz, 2 kHz. That is how we record reflexes, right? Threshold. I'm saying again, it depends on your intention. Suppose if you are doing SPAR, sensory prediction using acoustic reflex, okay, so where threshold of each intensity is very important, right? Then you've got to measure this way. You understand? But I am interested. Suppose a person is there, okay, a unilateral conductor, Okay, I want to find out, confirm whether this is unilateral conductive or not. So what my intention is to see whether there is conductive or SF. So I come and put the probe. Okay, so it means it should be a not mild, moderate conductive. So a good conductive hearing loss out in 1 year. So then I'm coming and putting acoustic reflexes. I'm presenting 501 k2k, right? Just at 500 hertz when I present, right? At 110, reflexes are absent. The reflexes are content. Did you get it? Can you get that? So all the reflexes can be rounded out to one measurement, one intensity, one frequency. You understand why? Because though we read this detail 500, 1k, 2k, etc., etc., it's not all of this value what we take to interpret. Right? Our interpretation is, have you ever asked Zerger box pattern which frequency we should plot? I told Zerger box pattern is there which says presence, absence, etc. But you have 4 frequency distribution. That decides rest of my reflex interpretation. So just the starting of the reflexes, you do a very sensitive and very accurate measurements, then you can easily interpret rest of the values, and it just takes less than 10 seconds, isn't it? Less than a minute. How much time do you say that to equate pressure adequately and then measure and 500 hertz value at 105? How much time it would take? Less than a minute. Right? So that's all it takes to do an reflex. So there is no need of doing much in that. But then, as I told you, in your, those are advanced interpretations. But then when you initially do it, you have to do it very sequentially so that you learn all the steps. Right? And then you yourself will learn so many techniques. Whatever I am teaching is not what you have to learn. You can learn many things by yourself. Altitude calibration you're supposed to do every day before starting your measurements. Okay, just to see that your instrument is calibrated. It's not an internal calibration. This is called as altitude calibration, only pressure calibration. Okay, so you have got acoustic reflex, acoustic reflex latency test, acoustic reflex sensitivity, multi-frequency, and other things. Okay, so now first let's layer, but ideally you have to do it in content layer. Okay, so time base 15 seconds, right? 15 seconds. Okay. Let's reduce it to
10.